This is Geeta Mahalakshmi from Ravindra College of Engineering for Women. Today we are discussing about case study on solar power generation. This is the block diagram by using solar power generation. Now we will design to the solar power generation for which components are mainly used. We are taking solar power panel or PV array, it having to the two inputs irradiation and temperature. Irradiation and temperature acts as the inputs and we are connecting to the home. This is the title of the solar power generation for home. So we are taking to the home. Home having conducting to the AC voltage. Solar power conducting having DC. So we are converting to the DC to AC. So we are using to the inverter. Inverter is a converse of the DC to AC, not of the pure AC. So we are taking to the change of the DC to AC to change to the boost to the converts of the its boost converter is mainly used to the here we boost converter we are using to the change of the DC of voltage to the inverter to the pulse generator to home. This is the process. The solar power is using to the boost converter, it is the inverse of then to the pulse generator. Here we using to the pulse generator. Pulse generator mainly occurs to the generate the pulse generator mainly for the pure of the AC. This pulse generator having to the LC and LOs. Pulse generator having converts to the sine wave of the AC. So we having to the AC, we have to the solar power generation has a maximum of the afternoon time. Morning and evening times we don't have to the solar power to generate, because here solar power generation having to the maximum power in afternoon only. For DC boost having we connecting to the parallel of the RLC circuit. It's mainly occurs to the change of the signals. Let's open the MATLAB on online. Open the MATLAB in online and check the where is the Simulink, and you have to the command box type in Simulink. We will be get the Simulink. In Simulink we have simulation part and go for library and search which components are you are used. First we are using to the solar or power panel of the PV array. It is having to the two inputs. Solar power panel. Solar power panel having to the two inputs IR and temperature. Let's go on another of the inputs of the constant. We are taking to the constant value for the IR and temperature of the PV array. Connect the connections of the PV as a input. First input taken has a 1500, second input has a 25 degrees Celsius of the temperature. Next take the scope for the see the output of the every signal. Here scope is the mainly output of the signal. Now take diode and IGBT diode. It is used acts as then to the converts. And take the universal bridge. It is the converts acts as then to the converter. We have to rotate on control plus I. It is rotates as in inputs of the its. Take the pulse width modulation generator of the second level. And next take voltage measurement. Voltage measurement acts as a converts the voltage to the range of its PV pulse generator and scope of it. Voltage measurement is connected with to the scope. Now take parallel RLC branch to change of the capacitor and resistor and inductor we have need. Now take the all the components as required we have shown in the figure. Capacitors to inductors to and resistor. Resistor and inductor is mainly used for connect the all the components as shown in circuit. Now we are seeing to the PV inputs of the IR 1500. Temperature is 25 degrees Celsius. We are connected with the voltage measurement to measure to the scope. Now we are connected to the IGBT and pulse generator to generate of the signals. Now we are connected to the capacitor to give of the voltage generator of the second output. Now we are connected to the universal bridge for the pulse pulse width modulations for the third output. We are connected to the inductor, capacitor and resistor for the proper output for the its voltage measurements is connected with to the scope. Pulse width generators acts as then to the change. Now see the outputs of it. First output is the 150 plus of the voltage and second output having to the scene 650 plus of then its voltage, and third output has then to the we will get sine wave. Using of the inductor and resistor we will get as a sine wave as shown in figure. This is the output of the solar power generation for home. This is the final circuit for it. These are the components used for the solar power generation for the home. These are the applications of the solar power generation for some applications are in given.